Hi guys, in this video we will feature worksheet 4.6 solving for parts of a right triangle. So far, what have we discovered? We've been investigating ways to solve for sides. Now let's talk a little bit about what we have to have. The first one we talked about was the Pythagorean theorem. Now the Pythagorean theorem basically states that the sum of the sides squared is equal to the hypotenuse squared. Or the way you've heard it, a squared plus b squared equals c squared. So yes, both of those will definitely do. So let's talk about what you have to have in order to be able to do that. Well, you're going to need to have two different sides. So if we are going to use the Pythagorean theorem, we must have two sides. Now, it could be a hypotenuse and a side, in which case we would be subtracting, or it could be the two smaller sides, and that would work, but we use addition. Again, it's a squared plus b squared equals c squared. The second thing that we discussed was the process of using trig functions. Yes, you can use trig functions, but when? We can use trig functions only when we have one side and one acute angle of a right triangle. All right. And we'll look at some of those examples again. I know you guys have had a great Thanksgiving break. So there are two possibilities there, the Pythagorean theorem, or we're going to use trig functions to be able to solve for sides. What about our angles? Well, if you go back to Unit 2 test, then we always had the triangle sum theorem. And that is to say, the sum of the interior angles of a triangle must equal 180 degrees. And in the case of right triangles, then you have this idea that the two acute right angles of a right triangle must equal 90 degrees. And again, we're still looking at that triangle sum theorem and just looking a little bit further. But we also figured out before we left that we could use the inverse trig functions. And when are we going to do that to find angles? But what do we have to have in order to begin with this one? Well, we would have to have two sides, and of course, knowing that it's a right triangle, you know that you'd have that one right angle, right? So how do we do this? You must have two sides of a right triangle. Now we're going to look at some of these examples, but what we know is that we can't break any of these particular rules as we move ahead. Now, in this video, I'm going to be featuring some of the odds so you can, and I might actually do number 6, but you're going to do the ones that I don't do on this page. So let's take a look at number 1. And as I'm looking at it, I don't have any angles, and I do see that I have 2 sides. So what would I be doing on this one? The Pythagorean theorem. Again, I'm going to take 15.4 and I'm going to square that, maybe faster to type it a little bit. I'm going to take 15.4 and that has to be squared. And that does mean that I'm taking it, squaring it. And then I'm going to add that to, or am I going to add? Well, the first thing we need to understand is 15.4 a hypotenuse? What are we looking at? And we do see that it is across from right across from there. So I do see that this one is actually going to be the hypotenuse. So that is definitely our hypotenuse right here. So I'm going to label that one. We practiced that also, labeling our A, H, and O before you left. And knowing that it's the hypotenuse, I do still have to square it, but I'm going to go back and I'll actually end up subtracting on this one because it's the hypotenuse, right? And I'm going to subtract the leg squared. And when do we do that? When we're looking for something smaller, which is one of the other sides. Don't forget to square that, and then we'll find our answer. So I'll go ahead and use my drawing tool to put that on there again. And so I'm going to take 15.4, square it, and subtract 4.8 squared. And then I'm going to take the square root. And when I do, I get the approximate length. But one thing you want to tell yourself is I know that it's going to be smaller. So I'm going to definitely subtract. Why? Because the hypotenuse must be the longest. And so when we do that, we get approximately, when we round to the nearest hundredth, we're going to get approximately, that's the symbol that I just drew right there. It's going to be 14.63. Now, I'll move to number 3 on this one, and I'm being asked to find, um, I see what I have. I have 2 sides, and so what am I going to do? Use trig ratios to find that angle. So I'm going to label my A, H, and O, but many of you guys have figured out that, yes, Pac-Man, you can always use Pac-Man to help you find the opposite side. This is going to be our opposite side. We're labeling our A, H, and O, but first we have to know where our angle is. 46 is our hypotenuse. 11 is our opposite side. And then we know that we're going to set up our trig ratio using sine. So the sine of the theta, and I'll have to draw that one because I don't have that either. Hold on. Sine of theta. I'm going to draw it. It'll be faster. It looks like a 0 with a line through it, the sine of theta. There we go. Theta degrees. We're trying to figure out what that angle is going to be equal to, and what are we looking for? It's going to be 11 over 46. Why? Because sine is opposite on top of the hypotenuse. Good thing to remember, sine and cosine will always have a larger number on the bottom of your fraction. Now, this is when we had to press our inverse key. Remember that one? You might want to put -1 right up here just to kind of remind yourself that you do that. When you do this correctly and you round to the nearest degree, you get 14 degrees. So go ahead and write that on there, 14 degrees. Again, this is just a quick review of what we did before we left. The next thing that we're looking at will be actually number 6 because, well, actually, I'll continue on with number 5. This is an example where we're going to add. We could use the Pythagorean theorem. to find this. All right. And I do see this time I'm looking for the hypotenuse. So, unlike number 1, when we subtracted, we're going to take 9.8 and square it. Yes, we do. And we also need to square 4.2. Again, this is the Pythagorean theorem. But this time we will not be subtracting because we're not really looking for something smaller. We're looking for something larger. So we're going to do a squared plus b squared. And don't forget to take the square root of these two. I did kind of show a few of you guys how to lay all of that out to make certain that you didn't do that. And we get approximately, how long is that? That's going to be 10.66. So we get 10.66 when we use our calculator for that particular function. And then I'll also look at number 7 on this one. And when I'm looking at number 7, this is just a quick review, identifying my reference angle. What am I looking for? I have one side, I have one angle. So what am I going to do? I'm going to use those trig functions. Pac-Man spits out the gumball. This is my adjacent side. And then I know that I'm using tangent, and the tangent of 57 degrees is going to be equal to opposite over adjacent. Remember, always have the angle traveling with tangent. Since the x is up high, we're going to multiply to solve this, but what we talked about is the tangent of 57 is really just a decimal. It's a ratio. So we have x over 18. When the x is up high, we do multiply. Please do put this side in first. Again, we're going to enter that into our calculator first. And so what is it going to look like? I'll type it down here. I'm a little faster. So we'll take 18, and we're going to multiply that by the tangent of 57 degrees. And when we press equal on our, and we round to the nearest hundredth, we're going to see 27.72 is our answer. So just as a review, I want you guys to go ahead and do 2, 4, 6, and 8 on this side. And I have video number 2 on the way.